Okay guys, now we're going to talk about ionic nomenclature with polyatomics. We've talked about simple ionics, transition metal ionics. Now we're going to talk about polyatomic ions. Poly means more than one. Atomic means atoms. So this means more than one atoms in an ion. First thing, you're going to still crisscross the charge, but the polyatomic ion will be put into parentheses if there's more than one. If the overall charge must still equal 0, as it does in all of our ionic compounds. First example, we have aluminum nitrate. So our ions, let's look at our ions. First one, aluminum, right here is in group 13. It has 3 valence shell electrons. So our first ion is going to be Al. You should know now it is much easier to lose 3 than gain 5. So it's going to lose 3. That's its charge, or its oxidation number. It's plus 3 because it's losing 3. It's losing negativity. Nitrate. Now, nitrate, if it ever ends in ATE, that should be a big indicator that you will not find that on the periodic table. You're going to find that on the back of your periodic table on your star reference sheet under where it says polyatomic ions. Remember, poly means more than one, atomic means atom. So all of these ions are going to have more than one atom. Remember, ions means it has a charge, which means it has lost or gained electrons. So all of these have a charge, if you notice. Okay, we're going to look for nitrate. So let's go down here and look, and you will find nitrate right here. It is the NO3 minus. So it is all of these atoms. There's 1 nitrogen, 3 oxygens, and the entire thing has a -1 charge. So now we're going to do like we always do in our ionic compounds. We are going to crisscross. So we have an Al with a +3 charge and an NO3 with a minus charge. That -1 is going to go down by the aluminum. And we never put 1s. This 3 is going to go down by the nitrate. Now, since there's more than 1, we have to put parentheses. So we're going to put NO3, and then we're going to put the 3 down there, which means there is 1 aluminum and there are 3 nitrates, 3 of these NO3s. So it looks like 1 aluminum, and then we have a nitrate over here, and a nitrate over here, and another nitrate down here. So our final formula after we have simplified everything, and this is already simplified, 1 and 3 is the lowest that we can go, it will be AlNO3. 3. Okay, so aluminum nitrate looks like AlNO3, 3. Next example, we have ammonium phosphate. Ammonium is an ion. You can find it right here. Ammonium is NH4+. It is the only positively charged polyatomic ion that you will see, that you have on your chart here. So just memorize it, ammonium. You're not going to find it on the periodic table. This entire 5 atoms here, this 1 nitrogen and 4 hydrogens, has a +1 charge. Phosphate, it ends in ATE, which means you're not going to find it on the periodic table. You need to look under your polyatomic ions. Phosphate, right here, is PO4 with a -3 charge. PO4 with a -3 charge. I would like for you guys to go ahead and start putting your polyatomic ions in parentheses. It is not like that on here, but your PO4 actually looks like this, and there's got to be a 3- there. Sorry, I marked it out. Now let's crisscross. So our metal always comes first. This is not a metal, but it is a positively charged ion. It acts like a metal, so our cation is going to come first. NH4 with a +1 charge, and PO4 with a -3 charge. That 3 goes down by the NH4, and since there is more than 1, we have to put the parentheses. And this 1 goes down by the PO4. Since there is only one, we do not have to put the parentheses around the PO4. It is okay if you do, but you won't see it like that on a test or any other thing. If there's only one, you don't put the parentheses. So our final formula is NH4, 3, PO4. This is a 3. Next example, calcium hydroxide. So let's look at our ions. So we're going to look at the periodic table. Calcium is on the periodic table. It is right here. It is in group 2, which means it has 2 valence shell electrons. It's easier to lose 2 than gain 6. Losing 2, that's its oxidation number. That's its charge, plus 2. Hydroxide. It ends in IDE, and if you remember, a lot of our anions, fluorine, chlorine, bromine, they all change the endings to IDEs, but you are not going to find a hydroene or a hydroxygen or anything like that over here, so that should be a big hint to tell you to look on your polyatomic ions chart. Hydroxide is located right here. It has an OH minus charge. So I'm going to put this in parentheses, an OH with a -1. Okay, let's crisscross. We've got our Ca plus 2, our OH with a -1. That -1 goes down, or the 1 goes down to calcium, but we never put 1s. This 2 goes down by the hydroxide. Since there is more than 1 on an OH, we have to put the parentheses. So it will be OH and then 2. Our final formula, we cannot simplify the 1 and 2 anymore, so it's simply CaOH2. So the formula for calcium hydroxide is CaOH2. Guys, if you do not put the parentheses here, this is what it will end up looking like. Ca and then OH, and then you put your 2 down here. That is a totally different compound than CaOH2. This has 1 calcium, 1 oxygen, and 2 hydrogens. This has 1 calcium, 2 oxygens, because there's 2, and that means there's 2 O's and 2 H's. And there's only 1 here. This is a totally different compound than each other, so make sure you put your parentheses. Copper 2 sulfate. This is a transition metal. Copper looks like, copper right here, it looks like Cu. Since it's a transition metal, they give us the Roman numerals. That tells us that it has a +2 charge. Copper 2 means that's its oxidation number. Sulfate, it ends in an ATE. That's a big indicator right there. You're going to find it on your polyatomic ions chart. Sulfate is right here. SO4 with a -2 charge. So SO4, I'm putting parentheses around there with a -2 charge. Now we're going to crisscross. So we got Cu +2 charge and an SO4 with a -2 charge. This 2 is going to go down by the copper. So we've got copper 2. This 2 is going to go down by the sulfate. So we put parentheses and we do SO4 with a 2. Now since this is an ionic compound, we need to simplify. 2 and 2 have a common denominator of 2. So 2 divided by 2 is 1, and we never put our 1s. So we're just going to leave it at Cu with no 1s. SO4, we're going to leave as SO4. This 2 divided by 2 is 1. And since we only have 1 SO4, we do not need to put the parentheses. So the formula for copper 2 sulfate is CuSO4. Last example, we have zinc chlorate. Zinc is right here, Zn. Okay, now it is a transition metal, and if you remember back to the very first video that you watched, there are 3 transition metals where their oxidation numbers never change, and it happens to be these 3 right here. And you can remember them by, or you can just remember their oxidation numbers by the same way we remember all these others. Silver will have a 1 oxidation number, +1. Zinc and cadmium always have 2. So these are the ones that do not have to have the Roman numerals behind them. So zinc has a 2 + 2 oxidation number. Now we need to look for chlorate. It ends in ATE. That's a big indicator. It's not on the periodic table. You're going to find that on your polyatomic chart. Chlorate is right here. It is ClO3-. ClO3 with a minus. I'm putting parentheses around it. It has a -1 charge. So all 4 of these atoms bonded together has a charge of -1. So now let's crisscross. So we're going to do Zn, 2+, and we're going to put our polyatomic in parentheses with a -1. That 1 goes down by the zinc, and remember we never put 1s. This 2 goes down by the ClO3. Since there's more than one ClO3, more than one chlorate polyatomic, we have to put parentheses. So it's ClO3, 2. And that is our final formula. Zn, ClO3, 2 for zinc chlorate.